Hello, Riley. I've got some of the questions that you asked about here. At least I think I've interpreted correctly which ones you're asking about. And so I'll go through part C on this video, and then it gets kind of long, and the YouTube won't upload it anymore. So I'll have to send you a second video for part D. Okay. Starting off with this question with the 4 cards dealt from a deck of 52. So just in general, 52 choose 4 is how many hands you can possibly make, right? Because there's no restrictions at all there. That green is hard to see. I'm going to switch to a different color here. So when they start to break it down and they start to put restrictions on the kinds of cards that you can use, then it's just going to change the number of cards that you have to choose your 4 from. So if it says how many hands will contain all face cards, well, a face card is a jack or a queen or a king, and then there's 4 suits, so there's 12 times, or 4 times 3 is 12, right? So that's just going to change this scenario to having 12 cards to choose 4 from, and you can write that as 12 choose 4 like that, or in the brackets notation. It means the same thing. How many hands will contain no face cards? Well, there's 2 ways to do that. One is we already have an answer from up here of the way to choose 4 cards from the deck with no restrictions. And here we're going to have an answer for the restrictions being just face cards. If you want to take A minus B, you're going to get your answer there for no face cards. The other way to do it would be to say if you got 12 that are face cards, you've got 40 that aren't. And so we're choosing 4 from that 40, and you could write that again as 40 choose 4. How many hands will contain only spades or clubs? Well, spades and clubs is half the deck, right? So that's 26 cards, and we're choosing 4, and so that's how many different ways we have of choosing those cards. And how many hands will contain only hearts? Hearts are 1/4 of the deck. They're one of 4 suits. And so we've got 13 to choose from, and we're choosing 4. Okay, that's all there is to question 1. It's no harder than that. Let's just change. I'm going to change pages here because I've got the next question on a separate page. Here we go. And we are putting our name in a hat along with 15 other people, and we're going to choose 3 of those names for a prize or something. So how many different selections of 3 names are possible? We have 16 names to choose from. We're going to choose 3 of those. Okay. How many of the selections include your name? Well, in that case, one way to do that would be, let me see if it's, it's funny, it'd be easier to go down to part C first because it says how many of them do not include your name. If we start there, let's do that. 15 are left if you take your name out, and so there's that many ways to choose it with your name taken out of the hat. If this is the total number of ways to choose with your name in, and this is the total number without your name, then if we subtract those, if we just take A minus C, we'll get that answer because that would tell us how many extra there are that include just your name. And that's the easiest way to do that. Sometimes these are just logic. So let's switch pages one more time. Question 3. Okay, and this one, as I said in the home page there, it should have said of the 4 digits. We're making 4-digit numbers, not 5-digit numbers here. If each digit must be different, then what we're going to do is we're going to kind of think of this as having, it's our 4-digit number, and so I'm filling in 4 blanks for those digits. And if every digit has to be different than when I start out, I've got 4 numbers I can choose from, right? Now, I'm going to multiply all the way down here, but I've used one of my numbers, so now I only have 3 left to choose the 3rd digit from. And then for the second spot, I only have 2 digits left, and for the last spot, I only have 1. And so there's a total of 24 ways to choose the digits in that circumstance. Now, if the digits can be repeated, that changes things because I've got 4 ways to choose my first digit, but because whatever number I chose kind of goes back in the pool and I can choose it again if I want, that means I have 4 choices for the second digit, and 4 choices for the third digit, and 4 choices for the fourth digit. And so that one becomes 4 times 4 times 4 times 4. I think that's 256, 16 squared, right? So if the number must be an even number, then what we're going to do now is, here's our 4 blanks. We're going to start at the other end because only 2 numbers can go at the end and still make this an even number, right? It has to be the 2 or the 4, or else it's not an even number to begin with. So I've already used one of those numbers there, which means I've got 3 to use here. Now, times 2 times 1. And the reason I hesitated there was that question didn't say whether they could be repeated or not. So if there's no repeats allowed, then this would be the answer. If you are allowed to repeat your digits, then we would still have only 2 choices for the last one, but we would have 4 choices in each of the other spots. And so in that case, it would be 4 times 4 times 4 times 2. And so that question's a little ambiguous. It doesn't actually explain it, and so you'd be fine with either answer there. It's always a good idea to explain, say something like, I'm assuming that I'm allowed to repeat digits, or I'm assuming no repeats are allowed, and then I'll understand what you're doing there and make sure you get credit for your work, okay? The last one says the number is greater than 4,000 with no repeated digits. So 1, 2, 3, 4 blanks to fill, and if it has to be greater than 4,000, it means it has to start with a 4, right? And so there's only one way to do the first digit. And then, if we're not allowed to repeat, we have 3 ways to choose the second digit, 2 ways for the third, and 1 for the last. And so there's 6 different numbers we can make under those conditions. And quickly, I'm just going to go over to the next page. And this should finish out part C, I think. The questions you asked for were 1 to 4 in part C, I think. Yep, and then I'll do D on a different video for you, okay? So we have the probability of a success being 50% for car 1. And for car 2, your neighbor's car, we have an 80% probability of success. So if we're looking for the probability that we'll have a failure, in other words, that the cars won't start, then the first car is a 50-50, right? So for the first car, we have a 50% chance that it won't start. And when it says neither car will start, what they're saying is neither the first or the second, so both cars won't start. So the first car won't start and the second car won't start. So won't start for the second car looks like this, doesn't it? Because it's the opposite of the 80% chance of starting. It's a 20% chance of not starting. And so that gives us 0.10 for the probability of neither car starting. Now, the probability that both cars will start, we have to do 50% for the first one and 80% for the second one, right? And so we want both cars to start. We need to multiply the probability of success of each together. That's an and. So that'll give us 40% there. That's a 0. All right. So the next question says either both cars will start or neither car will start. So we have a probability for both cars will start. That's 40%. And we have a probability for neither car, that's 0.1. And because it's an or, if we're dealing in percents, we'll make that 10%. So if we're dealing in or, we add those, and that ends up with a 50% chance that either both cars will start or neither car will start. And for the last part of the question, for part D, it says exactly one of the cars will start. So that one, again, is worded just slightly different so that we have to treat it just differently than the other ones. I'm going to just write over here so I have some more room. So exactly one of the cars will start. So that could be that car A started, but that would mean that car B can't start. Okay? Plus, let's switch that around. The probability that car B starts and car A doesn't. And so if we want exactly one of the cars starting, then we end up with 0.10 plus 0.40, which means that we have a 50% chance that exactly just one of the cars will start. So that's the probability of just A starting and B not starting, or the probability of just B starting and A not starting. And I think I had the wrong answer on the front of the page for that one. I think I have 90%, but we got 50, didn't we? Okay, so that's all of part C, and the video gets long and won't load to YouTube if I try and do much more. So I'm going to make you a second video for the questions in part D that you asked about.